So we're going to start recording. And now let's go ahead and start with this. Today we're going to talk a little bit about stuff that you've already done before. We're going to talk about Cartesian plane, or what we know it as rectangular coordinates. So when we're talking about the rectangular coordinates plane, we have two real axes that are intersecting by a 90-degree angle. So notice the angle over here between those axes is 90 degrees. So that to specify any particular location of any point on both directions, horizontal direction and vertical direction. Okay? Any point before, you learned about the real number line, where you have one line and then you have the zero, and then you allocated points and you said this is point number 1 or this is 2 or what have you. And the point over here, let's represent whatever variable you're looking at. Could be like an x value or a y value or what have you. Now, instead of doing it on one direction or in one dimension, if you want to say, because this line, the real number line, we were talking about one dimension. We were talking about horizontal. Now we're talking about vertical. Now every point on the rectangular coordinate system will have two coordinates. And let's say, for instance, we have a point A. It will have some value x, some value y. Okay. In this case, we call them x and y. It doesn't have to be x and y. It could be any other things, any other relationship between two variables. Yeah. It could be, for instance, distance and width. Yes. It could be pesos and dollar. The relationship between pesos and dollars. Yes. Whatever you can represent it in a rectangular coordinate system. Now, in this case, the first value is always the horizontal distance. Yes? So I'm going to call this line the x-axis. I'm going to call the horizontal distance in this case, so the horizontal line, the x-axis. We're going to call the vertical line the y-axis, since I specified the point A to have x and y value. Yeah. Now, of course, with the horizontal line and with the vertical line, we divide this into, say, this there or spaces that we will equally distance. So whatever this measure is from here to here, whatever you want it to be, they're the same from here, the same from here, and so on. And we do exactly the same for y. Now, it doesn't have to be the same distance, it could be something else. But each line must have its own distance, let's say. Yes. So let's say on the y-axis, I'm going to make it a little bit bigger, just to differentiate. Okay? Just to differentiate, because depending on the values, that's when we choose how far it is going to go. Okay? If I'm talking about small values like 1, 2, 3, or normal, you can say 1, 2, 3, 4, 5. Yes? But let's say I'm talking about thousands or millions. Are you going to go like 1, 2, 3, 4 until you get to the 1,000? No, I can call the first one to be what? 1,000, the second one will be 2,000, and so on. As long as you are consistent with your numbering. I couldn't say, for instance, this is 1,000, and this one will be 1,001. That doesn't make sense. If this is 1,000, that means this piece over here is 1,000. So this piece here is 1,000 as well. So that means after 1,000, I go to 2,000 and so on. Okay. As long as you keep the distances for the same values. And here I could go, for instance, 1, 2, 3. Or I could go all the way to here and call it 1. And then in the between, I divide it into portions to what I want. So that the distances between each thing is up to you to decide, depending on what kind of relationship we're talking about. Yeah? Now, with this, notice those two lines. We call this point, first of all, we call this point the origin. That point called the origin because it's the start for the x-axis and also the y-axis. And if you want to, you can call it, this has a value of 0, 0. Another way, 0 on the x and 0 on the y. Yeah? And no matter how big this is or what values you put on the first one, the very first one is always what? The 0 value. Yeah? Now, those two axes basically divide this whole plane into 4 portions. Portion on this side is limited by this line and that line. And then one portion is limited by this line, and one portion is limited by this line, and one portion is limited by this one. Yes? And we call each one a quadrant. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So those are the quadrant for those particular axes that you have. No matter which axis you're looking at, the quadrants are exactly the same. Yeah? Now, if we have a point or a coordinate points for one point, whatever it is, say x. What does x represent? X represents the distance from the y-axis along the x-axis. Yes? For instance, if I do have x to be 2, then I start at the y-axis and I measure 2. Okay? So let's say since this is, so this x would be right here, right? Provided, or it will take me along the x-axis 2 units to the right. Y represents the distance from the x-axis. So if this point happens to be, let's say, to 3, so that means I'm going to go along away from the x-axis 3 units. Yes? So if I go up 3 units, notice this is 1, this is 2, this is a 3. So that's where the point A would be. And this A has a value 2, 3. Every point on the coordinate system must have 2 values, x and y, and we call those coordinates. Yes? Any questions so far? No? Hopefully that gives you a review on the coordinate system for that. So now, the values on the rectangular coordinate system, let me erase that and start with a new one. The values for any point can either be positive or negative. So if we have, say for instance, let's take another point, 0, -2, and 3 for instance, then what does the minus represent? The minus represent, if I'm doing it on the x-axis, instead of going to the right, I'll be going to the left. Another way, instead of going 1, 2 this way, I'm going to go 1, 2 this way, and this is the x value for the point A. And the y value would be 3 units up. So now this is where A is. Now, if the y value happens to be negative, say for instance we have point B, and then B is equal to say 1, -2. Then again, the 1 for the x is positive. So I'm going to go to the right. Always starting from the 0, right? From the x-axis or the y-axis, wherever you are. So when I go on the first point, which is the x-axis, I'm here, right? Then it said we're going to go 2 units down from there. So I'm going to go 1, 2. So that point is 1, -2. And of course, both of them could be negative as well. So if we take a point, say C, to be -1, -2, then on the x we're going to go 1 unit to the left. On the y we're going to go 2 units down, because a negative means you're going down, right? And therefore, this point over here would be -1, -2. Yep. Any question on those? So now we said, instead of just saying x, y, those can be any. For instance, if we look at certain table, say this is the year, yeah? Say this is a year, and say this is say subscription for some kind of magazine or what have you, yeah? And let's say this is a subscription is represented in thousands, yeah? So what is that? First, let's start with say the year. They say 2014, we have 10. When it says the subscription is in thousand, let me write it down. In thousand. And I have 2014, I have 10. What does that mean? What it means, for whatever magazine is that, in the year 2014, they had 10,000 subscriptions. Okay? Say, for instance, in 2015, they have, let's call that 20. So 20,000 in 2015. Yeah? And let's take another value. Let's say 2016, it went down to say 15. Yeah? Okay, now, if I want to represent this in a rectangular coordinate system, every table that has a relationship between two things or two variables, we can represent it on the coordinate system. Yes? So let's go ahead and start with this. First step is I need to decide which one is which. Yes? So we have we have a relationship between two things. What are those two things? First, we have the year, and then the second information given is the number of subscriptions. Yes? So you make a decision which one do you want to make it horizontal, which one do you want to make it vertical. We like to say it doesn't really matter. Yeah? Let's go ahead and do that. But it's specific. For instance, I can say this axis represents, say, the year. So now when I talk about the year, I know I'm going to talk about I'm going to graph the year on this axis. So what does that mean? That means the first point over here has a first value of 2014. Does that make sense? Because I put it on where? I put it on the horizon. If you decide to go otherwise, say this is your year, yeah, so then this point would be, the second value would have how much? The value 2014. Yeah, why? Because I've decided the year to be which one? The vertical line. So it's important to know that the first point always represents, first coordinates will always represent the horizontal line. Okay, now, so we decided this is the year, then technically, or the only thing left for that is subscription. Yeah? Now notice here, we have a little issue. At 2014, which is a big number, right? And then After that, I'm moving up by how much? By 1. Yes? So how do I deal with that? One way to deal with it is, this is 0, right? Or you can call the 0 2014. It's up to you. And here's what I'm going to do. I'm going to make a cut over here. Yeah? And then I'm going to say this is what? 2014, 2015, 20. See what we did? Because I don't want to go for the year from 0 all the way to what? To 2014. There is no information there. Yeah? And that's a long line. So therefore what I did was I just cut that line, and this is the only important information I really need. Yeah? Now, in these, I can see we're probably going to go by, say, let's go by 5. Yeah? Or you can go by 10 if you want. So I'm going to take the first one to be, say, 5,000. Let's make that shorter, 5,000. Then the next one would be 10,000. Yeah? And then 15,000. And then 20,000. And then 25,000. We may not need to go up to 25, but it's okay. Then now, how do I relate this? So the first point is 2014 versus 10. Yes? So since I'm going by 10, let me just remove 3 zeros from each one. And then just specify over here. I'm specifying those numbers belong to what? They are in thousands. Yeah? Or you could have left it 5,000 and then read 10,000. Yeah? So now in 2014, I measure to there, and 10,000, this is the first point. Yeah? And then we have 2015, we're going to go up to 20. This is the second point. And then we have from 2016, we're going up to 15, and this is the third point. Yep. Okay, so this is what we call a scattered graph. Scattered graph is where you just go ahead, make all the tables, whatever coordinates points, and then determine which one is which, and then work it out. Yeah? And graph each one by itself. Okay. Any questions on the scatter graph? No. So now we talk about all of this in rectangular coordinates. Let's go ahead and talk about points on the rectangular coordinates. Let's say we have a point A. Yeah? Let's say we also have another point, let's call that B. Yeah? Now, we're interested to know, let's say those 2 points represent cities. Look at the map and you can see a city with a point in here, another city with another point there, right? And then you want to know how far away those cities are. And when we want to know how far away those cities are, we're not talking about driving this. When we want to know how far away from each other they are, we normally do what? We take a straight line between those two, and we measure what that line is. Yes? So for instance, let's say we have a city A here, city B here, right? And then there is a valley between them. Okay? Now, how far are these two? In order to go from city A to city B, by car, you probably have to drive, let's say, some road, whatever, to get there. We have a valley in there, and that's a long valley, and then, and both of these are on top of mountains, and so you have to go down the mountain around. You'll probably drive about half an hour. But it could be like, boom, you got there. So the distance between them is not all of this distance. It is simply what? From here to here, it's a straight line how far they are. You might stand on this mountain and then call somebody on the other one, hey, how you doing? And he could hear you. You see what I'm talking about? I'm not going to say they are like 20 miles apart or 30 because they're not. There could be like maybe half a mile or even less. So it is important to know how to figure out the distance on our rectangular coordinates between any given points. Yes? All right. On a rectangular coordinate system, I'm not going to put any numbers, but I'm going to say this value over here is represented by the distance from here to here, and we're going to call that the x1. Where it is the x value for point x. Okay? And now we're going to say the distance from here to here, we're going to call that y1. So now what do I know? Well, we know A, let me write it over here. A has an x coordinate of x1, y coordinate of y1. Make sense? Now let's go to point B. The point B is over here, right? If I project it down vertically and I measure from here to here, it will give me the x value of point B, correct? So let's call that, say, x2. Yeah? And let's call that, similarly, y2. Yeah? Because that's the y value. So now, if I want to represent P as a coordinate, as a point, I can say B has a value x2, y2. Yeah? Clear? And I'm not interested in what x1 is, what x2 is. I'm interested in the distance from here to here. Yeah? Notice, if I continue this line straight, that's a horizontal line, right? The line going down is also a vertical line, yes? So that means the angle between those two is 90 degrees. Yeah? Because the horizontal line and the vertical line, they cross the 90-degree angle. And this is the same angle we have over here. That's your horizontal line, that's your vertical, correct? Now, what do I know about this? Well, this is two vertical lines, right? These are two horizontal lines, right? So therefore, we have a rectangle. Don't we? And what do I know about rectangle? This portion and that portion are exactly the same. The line from here to here and the line from here to here are the same. Now, if I extend this line a little bit, or if I look at the whole big picture, we also have a rectangle on top, right? And this line here and this line here are the same. Yeah? What do I have in the middle? What kind of a rectangle is there? What kind of a triangle is this? It's a right triangle. Yeah? What do I know about Pythagorean theorem in a right triangle? Why do I have a right triangle? Let me put it over here. Any right triangle, where this is the right angle, this is C, let's call this A, let's call this B. Yeah? So what do I know about C? C squared equals A squared plus B squared. or the hypotenuse, always the side across from the 90-degree angle. If I square that, it will be the sum of the square of the other two sides, correct? Okay, so that means what? That means this line square, the distance from here to here, right? Equal the distance from here to here square plus the distance from here to here square. Yeah, all right, let's write it down. I'm just gonna name it, I'm just gonna call it some names, yes? Let's do the same thing we did here. We called the point across from the 90-degree C. So let me call this C. Yeah? And this one I called it A, the one on the bottom. Let's call this A. Let's call this B. And therefore, the relationship stands. So now I can say, not for this one, I can say for this one, C squared equal A squared plus B squared. Okay? Good. Now let's figure out what A is. What is A? A is the distance from this point to that. Correct? Yeah, how do I figure that distance? Well, I know x2 is the distance from here to here. Correct? That's what x2 is. And x1 is the distance from here to here. Yeah? So if I were to subtract this, what do I get? The distance between them. Yeah? So okay, and since this part and this part are the same, I can safely say A is a distance between x2 and x1. Yeah? So let's do that. So we know A is x2 minus x1. Okay, we need to figure out what B is. Okay, let's talk about B. Now notice, B is the distance from here to here. Yeah? And we said it is the same as from here to here. Okay. Y2 is the whole thing from here to here. Y1 is this one. Therefore, B will be the difference between the two. Same thing we did here, right? So if I take the whole thing and I take away this portion, I'm left with this portion. Correct? So now I can say B is Y2 minus Y1. So far, so good. Any questions? Inaya, let's go ahead and do. So now the distance C is what is the distance between A and B. That's what we're looking for, right? Now to represent the distance between A and B, we normally write it with a segment line on top of it. So that represent, we're looking at the segment AB. And the segment AB is start at A and ends where? At B. So we're looking at it. So you can relate it by this format. Okay, you're probably going to see that later somewhere. So now you know what it is. Okay? So if you have 2 points, let's say A, B, and you have a line on top of them, that represent the distance between A and B. You will see other ones. You probably see sometimes A, B like that with an arrow. That's different story. Okay? You'll probably see that in Recalc 2. But for now, we're not going to worry about it. Yes? Because I don't think we're going to get to it. So now we can say C squared, or the distance squared, equal A squared. But what do I know about A? X2 minus x1. Yeah? So I can say this is x2 minus x1 squared plus, what do I know about b? Let me erase part of this because I don't need the graph anymore. Yes? So now, but that's the distance squared. How do I find the distance? So we can say A, B equal, normally it will go plus or minus, because if you have something squared equals something else, whatever this is without the square would be the plus or minus of the square root of that. Yes? So that is square root of x2 minus x1 squared plus y2 minus y1 squared. However, because we're talking about distance, what do we do with the minus? We ignore it, because we don't talk about negative distance. Okay? Because the distance, the minus, does not specify the distance, it only specifies direction. Remember, when we talk about the coordinates, we say it's the distance from the x coordinate is the distance from y to x. Which way do we decide to go? Based on whether it's a positive or negative. So the negative simply states what? Direction. And when we're looking at distance, we don't care about direction right now. Yeah. Now, when we talk about, say, A, B with a vector, then we're talking about direction. Then we have to specify positive or negative. But now we're only talking about distance. Yeah? We don't worry about positive or negative. We just want to know how far it is. Yes? And we normally don't measure things. You don't say the book is negative foot. What? We just say, oh, it's 1 foot. That's it. Yeah? So every time you're talking about distance, we're talking about positive numbers. Yeah? And of course, another way of representing distance is by stating absolute value. You've heard of the absolute value, right? You always remember, absolute value of 3 is what? 3. What's the absolute value of negative 3? Why is that? Because when we say absolute value, we're talking about the distance the point is away from what? From 0. So if I look at the number line, say this is my 0, and I say this is 1, 2, 3, this is 1, 2, 3, that's your negative 3. Okay, the distance between 0 and 3 is 3 units. And also the distance between 0 and negative 3 is also what? 3 units. That's why the absolute value of a number is always simply what? Positive. Yes? I hope that was a new information. I don't know if you know it, but that's why the absolute value is always positive if you ever wonder about it.
So it's the distance from that number to 0, correct?
Right. Always, when you say absolute value, the distance from where you are to 0. Okay? Any questions? Okay, so this is the formula for finding the distance between any 2 points on a rectangular coordinate system. Now, does it matter if I switch these around? Not really. Why? Because the number is simply what? Square. So notice, if I have 3 minus 4 squared, and I have a 4 minus 3 squared, what do I get? Well, 3 minus 4 is a negative 1. And when you square a negative 1, you get positive 1. Yes? Now, 4 minus 3 is simply what? 1. And when you square 1, you get 1. So it really doesn't matter whether you put it x2 minus x1 or x1 minus x2. Yes? We just do it this way for making it look good. I start with 2, I'm gonna write 2 over here. I start with 1, I'm gonna write 1 over here. Yes? And of course, it does help for later on when direction really important and you're looking at the distance. Y2 minus Y1 is not the same as Y1 minus Y2. Yeah. But for now, because the fact you have a square up here, it really doesn't matter. So don't hesitate to just write whichever you want first. Yeah. So I could say x1 minus x2, y2 minus y1. I could say x1 minus x2, y2 minus y. Now, does this come first or this come first? It really doesn't matter again. Why? Because we're adding those. Yeah? So if I start y2 minus y1, x2 minus x1, it really doesn't matter. Because 3 plus 4 is the same as 4 plus 3. It's commutative relationship. Yes? So those relationships are commutative, and therefore, whichever way you put it, it really doesn't matter. Okay? Just remember, it is the difference in the axis, the difference in the y, and each one is squared. Hopefully this will make it easier for you to remember it instead of remembering identically what each one is. Okay? So let's take an example and see how we apply that. Suppose we have a point A has value, say negative 2, 1. I'm going to put positive and negative numbers, so this way you can go ahead and have both examples. Say B is, say negative 4 and 3. So we have 2 points. Hey, I was looking for this the other day. You usually have it over there last semester. Now here it is. Capacity of the room is 15 students. All right, so now let's say we have those 2 particular points, right? And of course, we're looking for the distance between A and B. The distance between A and B. Yeah? Good. So I will find that out. Well, we know the difference is, so AB is equal to the square root of, yeah? A difference in the axis squared plus difference in the y squared, yes? So x2 minus x1, y2 minus y1. Yeah? Now here's another thing is, which one is point 1, which one is point 2? I don't care. Yeah? Just apply the numbers. In this case, I can go the 2 axes, subtract the 2 axes, subtract the 2 y's, and I'm done. So what is that equal to? Well, the purpose of illustration, let's consider this is point 1, this is point 2, yeah? So this has an x2 value and y2 value, and this one has x1 value and y1 value, yeah? So now, based on what I have, x2 is negative 4 plus, and x1 is negative 2. The whole thing is squared. Plus, based on what we have, y2 is.
Why is the negative 2 in parentheses?
I'll answer your question in just 1 second.
Okay.
in 1 second.
I have a question.
Y2 is 3.
Oh.
And y1, which is, did I say plus here? I'm sorry, minus. Yeah? Because the difference, right? They have the difference. Now, he said, why do I have minus 2 in parentheses? It's always important. It's always important. When you do a substitution, to put the number you substitute in parentheses. Especially when you have a negative in front of it.
Because that makes it positive, right?
Yes. Now, I'm going to replace x1 by its value, right? What's the value of x1? Negative 2. So it's normally better to always put what? That when you do substitution, put inside parentheses. Sometimes it doesn't matter. Sometimes it does. Yes? Especially when you have a negative in front of it. Yes? Because, for instance, I'm going to give you just a quick example. If I have a negative, let's say x1, some number which is negative 3, and I'm going to substitute, say, a minus x1, and then I'm going to split it out. Yeah? Or even cube it, or what have you. Yeah? So now, we're going to say, whatever a, let's put this at 4. So how do I substitute that? It's going to be 4 minus, we do have a parenthesis already. Let's take that parenthesis, let's say it didn't exist. We still have x1 squared. Now, if I put x1 squared, guess what? Most of you are going to do like this. If you don't put parentheses, you're going to do, yeah? Is that correct? Now, what's going to happen? You're going to say 2 negative makes what? Positive. And then you're going to end up with 13. But if you put it in parentheses, it is what happens. You put that in parentheses. And now, the order of operation says to do what first? Parentheses. Yes? So now, what do I have raised to the second power? Negative 3. And negative 3 raised to the second power is simply what? 9. So now I'm going to end up with 4 minus. I'm still going to put the parentheses. 9. But that 9 is simply what? It's a positive. So now negative and positive makes me what? Gives me what? Negative. So it'll be 4 minus 9, which is.
So whenever a negative number is in parentheses squared, it becomes a positive?
Yes.
I didn't know
Any. Okay, let me put it this way. A negative. If you have a number inside a parenthesis, and then you have some value up here, let's call that x, whatever that value is. Yeah? It could be 1, 2, 3, 4, 5 million, I don't care. Yeah? Here's the thing. If this number is even, such as 2, 4, 6, 8, and so on, the result is positive. Yeah? If the number here is odd, such as 1, 3, 5, 7, 9, and so on, yeah, then the result of this would be negative.
So only
It's a positive only if the exponent is even. Yes? It's a positive if the exponent is even. It's negative if the exponent is odd. Yes? So keep that in mind. So now, but I always, anytime you're doing a substitution, a letter for a number, this is how I substitute. If I have x minus y squared, let's say x equals 5, y equals 3. It doesn't matter what numbers they are. This is how I substitute. First, I take the way x away and I replace it by parentheses. Yeah? And then minus. I take y away, let me take those parentheses out. I take y away and replace it by parentheses. On top of the y, I have a square, so the square root of parentheses. Yeah? Now I fill in the parentheses by the values of x and y. What is x? We said 5, so I put 5 here. What is y? 3. I put a 3 here. And this way, I never get it wrong. Yeah? So anytime you do a substitution, you should remove the letter, put parentheses, fill in the parentheses with whatever the value is. Yeah? This way you never get it wrong. But if you don't, now if you, when you become a little bit accustomed to it, and you already know what the result is going to be, you can figure out when to put the parentheses, when to take it out. Yeah? But for the beginning, always put the parentheses. If you don't need it, it's going to go away. If you don't need it, it's going to go away. You're not going to use it. But if you need it, it's there to use it. Yeah? So it doesn't hurt you to put parentheses. It does hurt you to miss it. So let's do this. So now we have, before I evaluate anything, I need to remove this parentheses, right? So now we have a square root of, so that's going to be negative 4. Negative and negative makes a positive. So that's 2 plus 3 minus 1 squared. Yeah? So now I'm going to evaluate each portion. Theta square root of top. Minus 4 plus 2 is negative 2 squared plus 3 minus 1 is 2 squared.
Positive 4 plus.
That's a negative.
I mean.
Oh, on the second, yeah, we're going there. So now that is equal to square root of negative 2 square it, you get positive 4. So let's put 4. You have a plus. And if I square the 2, I get what? 4. And 4 plus 4 is? And what's the square root of 8? Anybody has a calculator? The square root, not the square.
Oh,
It's 2 point something.
I don't have a square root.
You do, you just don't know how to use it.
Yeah.
Take your phone, flip it on the side, go to the calculator, and then give you a scientific calculator.
2.82.
Huh?
2.82.
2.82. Now, is that correct?
Approximately, yes.
Why not? Because the square root of 8 is not 2.82. 2.83?
Would you
Round
round
it? Exactly. Do I round it? Do I leave it? Do I do what? I don't know. If you're working on one sum, you better put exact value. Yes? Unless it's specified to round. If it's specified to round, then you go to decimal and you round it. If it does not specify to round, you have to put exact value. What's the exact value for the answer?
2, square root of 2.
Square root of 8. Clear on that? Now, unless, say you have a square root of 16, yeah, I can make that 4. That's fine, because it's its exact value. Yeah? I can make that 4. But if you go on the calculator and your decimal never ended, guess what? That's not an exact value. Because square root of 8 is not 2.82. What was after that? 82, whatever, right? It never ends. That's an irrational number. A rational number never ends. Yes? specifically when you say 1/3, yeah? If I say 1/3, what is 1/3? If you look at the calculator, what does it do? It gives you 0.33333, right? Now, if I say it's 0.3, is that correct? No, because I missed that 3. Yes? What if I say 33? Is that correct? I'm going to give you an example, why not? You have $1, you want to give it to 3 people. You give everyone 33 cents. What's left? 1 penny. Yes? Legally, you have to divide that penny among 3 people. Or you have to give one person a little bit more. That's not fair. Does that make sense? So exact value, 1/3. If the web assignment is asking for exact value, you have to put 1/3. If it says round, whatever rounded number they ask you for, you go for it. Then you put a decimal and you round it. But if it doesn't say that, and you just type 0.33, the answer for 1/3, web assignment will tell you wrong. Unfortunately, if the problem has 10 points on it, you lost 10 points just because you decided to run. Okay? So be careful when you're working with web assignment. Okay? So this is the only reason I wanted to go over this. Now you could have write this as 2 square root of 2, which is still acceptable because that's still an exact value. Just round, simplify. Yeah? But never change it to decimal unless they ask you to do so in the problem. Okay? Any questions? So this is how we found the distance formula, or how we use the distance formula in rectangular coordinate system. Yes. Another thing we want to look at today is called midpoint formula. Let's start again. This is my rectangular coordinate system. Yes? Let's say we have a point A, point B over here, and I'm looking for this point over here. Let's call that C. Yeah? And C is midpoint of AB. So C is the midpoint between A and B. Yes? Halfway between A and B. And let's figure out what is the formula for that and how we have it. So I don't have to go through all of the stuff I went before. So let's say this is your X1, yes, for point A. And let's say this is your X2 for point B, yes. And since C is the midpoint, this is X midpoint. Yes? This is the value for X. First of all, how many numbers I'm looking for to figure out the midpoint of a segment? Am I looking for one number or two numbers? Two numbers. Now, why? Because this point has a coordinates, yes? And those are the coordinates I'm looking for. And every point on a rectangular coordinate must have two values. Yes? Now notice, in the distance, we only look for one value. Why? Because we just measured. And that measure has to be one value. It couldn't be like 3 and 4. Yeah? But now we're looking at a midpoint. That means I need to look for X value, and I also need to look for Y value as well. Yes? So now we did this. Let's go ahead and do this. This is Y1. This one is Y2. And this is Ym. Again, Ym is the Y value of the midpoint between A and B. So technically speaking, I'm looking for the distance from here to here for the x value. Yeah?
Yeah.
And I'm looking for the distance from here to here for the y value. Let's take a look at one of them, and the second one will be exactly the same. Let's take a look at the x. Okay, now, because this is the midpoint between that and that, yes? It is also halfway between here and here. We go back to geometry. We should notice that if we take parallel line to the base and we cut the other side exactly halfway. Yes? So now we know this and this are exactly the same. Yes? So this is halfway between these two. Okay? So let's call this distance, let's call it A. Yeah? Okay, now xm equal. Xm equal. Now, xm is the distance from here to here. Correct? We're looking at that. So it is the distance from here to here, yeah, plus from here to here. Fair enough? So it is x1 plus a. It's x1 plus a. What do I know about a? A is halfway between x2 and x1, right? Let's figure out what that is. Well, the distance, this one would be what? I can take the whole thing and divide it by 2. Yeah? And then I'll get that. Isn't that correct? Okay, how do I find the whole thing and divide by 2? Well, the whole thing is all of this minus this. Yeah? Okay, so now let me write down what A is. A is x2 minus x1 over. So far, so good. So let's substitute. So I'm going to remove A from here, replace it by that. So what is this? Then xm is x1 plus x2 minus x1 over 2. Yeah? So for a second, any questions? No? Now, in order to add these, you need a common denominator, because those two are fractions, yes? So I'm going to rewrite that. Instead of saying x1, because I want to use a denominator 2, I can say this is 2 x1 over 2. Correct? And 2 over 2 is what? 1. So that's still x1, right? Plus x2 minus x1 over. Correct? All right. We don't need this anymore. Let's go ahead and erase that. Because both of them have the same denominator, I can put them all on the one denominator. Correct? So that's equal. I'm just going to say 2 over here. That's the common denominator for all of them. Yes? And then, when you add those with the same common denominator, you just simply add the numerator. Yes? So what are the numerators? 2x1 plus x2 minus x1. Okay? So now what is that? Well, x1 and x2, I don't know what they are. They're different. But this x1 and this x1 are exactly the same, so I can subtract. If I have 2x1 here and I take away x1, what's left? X1. And that's the midpoint, that's the x value of the midpoint between two points. Yes? What do you think the y value is going to be?
Same thing we repeated.
Same thing, but instead of x, it's going to be simply what? What? So that is the midpoint formula for any given line segment. Clear? So two things here we learned today. The distance formula, right? And the midpoint formula. So let's do an example on this one. So let's say A is a point, say we have a negative 2, 5, and B is negative 3, negative 6. Says find the midpoint between A and B. So let C be the midpoint. So I'm just going to choose a letter C. And that letter C, I'm going to call it the midpoint between A and B. Yes? So that will give me a little bit of so I don't have to specify midpoint every time. When I say C, then it's midpoint. Yeah? So now we need to find two things. We need to find x of C. We also need to find the y of C. Yeah? Then xc is x1 plus x2 over 2. Now, which one is x1? Which one is x2? Does it matter? Really doesn't. Why? Because we are adding. Yes? If I'm adding here, and if I switch those around, does it matter? No. So you choose which one if you want x1, which one you want x2. Yes? So here you go. I'm just going to put them in the order that we're given. Yes? So this is one that's 2, right? So one is negative 2 plus negative 3 over, and that is going to equal to negative 5 over. Now you can write that number, negative 2.5, which is fine. Because if you divide 5 by 2, you get 2.5. Yes? Because the division ends. Yes? Unless it says write it as a fraction, then you have to go fraction. Yeah? So what is the y value of C? I'll be y1 plus y2 over 2. Again, we have a 5 plus negative 6 divided by 2. And that's equal to 5 take away 6 is negative 1. Yeah? And that's your midpoint formula for this particular problem. Yeah. Now, a couple of things we need to do is really need to teach you how to use your calculator as well. Yes? So again, if you want a calculator, you can go to room E113, where you're gonna be going right now after this class, and then ask them for, you can rent a calculator from there for $10 per semester. So in other words, you sit there, you use it for one semester, at the end of the semester, you give it back, and then you're done, okay, after your funds. Now, if you have a phone for now and you want to use your phone as a calculator, you can use it as a scientific calculator. Take your phone, and then you open the calculator and you flip your phone this way, it becomes scientific calculator. Okay? So you can use that, but be careful with your phone. iPhone are different than Android. Some of them you have to put the minus first, and some of them have to put the number first, then the minus, and all of this good stuff. So be careful when using your phone. It is not easy to use. Yes. So this is one thing you should know. Any questions? No? All right, I'm gonna stop here for today. We hopefully covered part of what we're supposed to cover for the week. We will continue next time with graphing, and I already fixed your assignment. Now everything shows up what you're supposed to do this week, yeah? So when you register to WebAssign, you should see 2 or 3 assignments are gonna be due sometimes next week. All right, so I'll probably see you in the lab because that's where I'm going right now. All right. Have a good day, guys. Any questions online?
See you Tuesday.